On number 1, we're asked to graph this polynomial function, this polynomial equation. The highest power of x is 4. So it could be a little more complicated than the ones we've looked at, linear, quadratic, and cubic, where the highest power was 1, 2, and 3. But we're really not sure yet, so all we have to do to start out is just start plugging in the x values that are given in the table. If you plug in -2 for x, then when you raise it to the 4th power, what you can't see very well because it's on the edge of the video is that you can break it up into -1 to the 4th power times 2 to the 4th power, and then -1 times itself 4 times gives you +1, so you just have 2 to the 4th. That ends up giving you 16. Just 2 times 2 times 2 times 2 gives you 16. Then if you do -1 to the 4th power, gives you +1. And then the other easy values to plug in here are the 0, the 1, and the 2. They give you back 0, 1, and 16. And then the ones that are a little more challenging are these -0.5 and +0.5. So the negative part we already know is going to go away, but the 1/2 turns into 1 to the 4th over 2 to the 4th, so you get 1 over 16 for those. So now to graph it, we just plot those points. And when you're setting up your plot, it doesn't matter how you scale the x values and how you scale the y values. So just try to use some convenient numbers and a convenient scaling system based on the numbers that you found in the table. So that's what I've done here. X goes out to +2, y goes up to +16. And then 16 is easy to cut in half, you get 8. You cut that in half again, you get 4. So now I'm plotting that first point, -2, 16, -1, 1, -1/2, 1/16, 0, 0, 1/2, 1/16, 1, 1, and 2, 16. And now my job is to connect these with a smooth curve. And you can't know exactly what the curve looks like based on just these points, but it gives you a very good idea. And your first guess would be the correct guess, that it looks something like this. So it looks kind of like a parabola, but it's flattened out a little bit more. That will always happen with an even, with a polynomial whose power is even. So here our power is 4, that's even. So the shape of this thing I'm going to call an even degree polynomial. Or what can happen, if you have more terms after the x to the 4th, what can happen is that in the middle you can get a little bit of waviness going on. Like some little peaks and valleys. So I'm going to also call this a parabola type of shape with possible waves in the middle. And if we're thinking of it as a parabola, it's opening up as opposed to opening down. Then the second piece of information is the y-intercept. That's where your graph hits the y-axis. So that's just at x equals 0, and we got y equals 0 for that point. Then on number 3, if you look at what happens as x goes out to the right, the y values go up, so we'll say they're increasing. As x goes out to the left and approaches -infinity, the y values are also going up from right to left, so we'll say increasing there as well.